Overview of thermochemistry part 2. So we are continuing our discussion of enthalpy and picking up with enthalpy of reaction. So if you have a reaction and it's given an enthalpy value at the end, this is going to be some value and the units of that are going to be kilojoules per mole. I like to think of this as kilojoules per mole of reaction because then that helps me think about how to do calculations with it. So the sign of this matches your endo and exo situation. So if this is exothermic, that will be negative. If this is endothermic, that will be positive. If you're doing calculations with enthalpy, you want to make sure that you always think, if you are given information about endothermic and exothermic, to make sure your sign matches. You can treat this as a unit conversion using stoichiometric factors. So for example, if you were given the mass of C, you would first convert it to moles like we almost always do. And then once you've got your moles of C, you would multiply by this divided by 2C. So remember I said this is like moles of reaction. In the reaction, you are using 2C for every one reaction. And so that's what you would do with that coefficient. We could also flip this calculation the other way around. You could be given a particular amount of energy and asked to find the mass of one of these species. When you need to use this, you're usually given a reaction with a delta H at the end and the amount of one species, and then asked to find the energy, heat, or vice versa, given energy or heat and asked to find the amount of. Bond enthalpies is the only situation in which you do reactants minus products. So I like to think of this as bonds broken minus bonds formed. This is not on the equation sheet. It is helpful to draw Lewis structures so that you can count the types of bonds that are present in each of the species and then multiply by the coefficients. You are always going to be given bond enthalpy data to do this kind of reaction, this kind of calculation. Enthalpy of formation, you're going to use this equation in AP chemistry that is on the equation sheet. It is the summation of your delta H, your enthalpy of formation of products, minus the sum of your delta H formation of reactants. You're going to be given those values for the specific species, remembering the elements in their elemental form are 0, including your diatomics. So you will not necessarily be given those. You're going to multiply by the coefficients of that species in the reaction. And you're going to watch out for your order of operations and your signs. You're going to do the summing first, sum your products, and sum your reactants, and then subtract them. Your delta HF, again, is the enthalpy of formation. That's the amount of energy to form that compound from its elements. You're always going to be given the delta HF data for some species. Keeping in mind that we can also do this if you have the formation of a binary compound from its two elements, then that delta H of reaction is essentially equal to your delta H of formation of your product there. Hess's law, you can sum energies of steps to give an overall reaction. That's what Hess's law says. So if you're going to manipulate the steps so that they sum up to give the overall reaction, keep this in mind. If you're going to flip your reaction, you're going to flip your sign. So if your reaction, if you need your products to become your reactants and you switch it like that and you had a negative delta H, now that delta H is going to be positive. If you multiply the reaction by a term, you're also going to multiply your delta H by that term. So if you need to double a reaction, you're going to double the delta H. When you're done doing that, you're going to add all of your reactions, canceling out things that appear on both sides. And that means you're also going to add your delta H values. You're going to know that you're going to do that if you have multiple step reactions that are provided and then you're asked about how they relate to the overall. I have also seen them ask questions where they give you the overall delta H and ask you to calculate the delta H of one of the steps. There you go. That's a brief overview of thermochemistry.